So our next set of notes is 3.10. And 3.10 talks about inequalities. So here, if we want to know where is this less than 0, keep in mind that our function notation is always the same as y, right? So this is asking me for what x values are the y values less than 0. Well, we know that y is less than 0 underneath the x-axis. So here, y is less than 0 in between -1 and 1. And now since this has the or equal to, that's actually going to be -3. That's actually going to be brackets because it is 0 at these places. So really, you're going to follow whatever this sign is. So for example, if I was looking at the same graph, what happens? Why are you yelling? If I was looking at the exact same graph and I was asked where is m of c greater than 0? Okay, baby, I'll be right there. I would have said that it is greater than 0 from -infinity until -3. Use the parenthesis because this is just greater than. And then from -1 to infinity. Okay, let me see. Want word party back? Okay, what do you want? Here you go. Okay, so they're just really asking you for what x values are you either above or below the x-axis, above or below. And if they use the or equal to, then use brackets. And if they do not use the or equal to, then use parentheses. Okay? So when you're dealing with a rational or a polynomial, inequality, what you're going to do is you're going to get your zeros. So pretend this was equals 0. You would say, okay, x equals 1 and x equals 8. We're going to plot those numbers, 1 and 8. And when we do that, you can see we've broken the graph up into 3 sections. Now, keep in mind, I put closed dots because it had the or equal to. If it did not have the or equal to, I would have put open dots. Okay? So we've broken the graph up into 3 sections. For my first test value, I'm going to pick any number to the left of this first dot. So let's do 0. And then I'm going to take 0 and plug it in. 0 minus 1 is -1. 0 minus 8 is -8. That's -1, -8. I got 8. Is that true? No. So this is false. Now, for my second one, I'm going to pick a number in between my 2 dots. So let's do 2. And I'm going to test that. Is that true? Yes. Okay, and then for my third, I'm going to pick a number to the right of my second dot. So let's do 10. Is that true? No. I'm just like double checking right now to make sure that those words are true and false. There's something like that, but I want to make sure I'm telling you the right thing. What's wrong? You're doing a lot of oh no's over there. Where are you? And I don't even see these on here. Maybe they got taken off.
No.
No, you don't want it? Oh, there it is. Found it. Yeah, I was right. True and false. So then, if this was the section where it's true, then this is the section that I shaded. So had it been true here, I would have shaded this. Had it been true here, I would have shaded this. Since it was true in the middle, that's what I shaded. And so then my inequality here would be 1 to 8.
What?
Okay. Now for a larger polynomial, the steps are the exact same. We're still going to solve. So here we get -6, 7, and 6. Honestly, the easiest way to do this is to make yourself a number line. That way you can mark on your number line. These would all have open circles this time because there is no or equal to. Now, I'm going to test a value on this side of -6. So let's pick -10. So when I plug in -10, -10 plus 6 squared, -10 minus 7, -10 minus 6, plus 6, -10 minus 6. I got a positive number, a big positive number, but I got a positive number. So then the area over here is true, so I'm going to shade it in. Okay. Now let's pick a number between -6 and 6. We'll say 0. If 0 is an option, use 0 because it's always the easiest. Because then this would just be 4 times 6 squared times -7 times -6. I got a positive. Again. So then this is true also. So I'm going to shade this section in also. Okay, now let's do a number between 6 and 7. So let's do 6.5 would probably be easiest. What's up, baby? I know, this was a long one. 6.5 plus 6. You want some water?
No.
6 minus 7. Oh, I forgot the 0.5. I hear you, sweet baby. That was a negative. And so that's going to be false. Oh, Mommy needs that. Here. So I'm not going to shade in that section. So then now let's pick a number bigger than 7. So we can do positive 10.
Yeah.
I'm just going to go through and delete all my negative signs. You got a positive again, so this was true again. So then I would say, okay, I would say negative infinity to -6, -6 to 6, and 7 to infinity. I just realized this one wanted an inequality, not interval notation. So that would have been 1 is less than or equal to x is less than or equal to 8. Okay. Honestly, even if they don't ask me to, this is how I do them. I don't really know of another way. All right, so if you're given a quadratic like this, just get everything on one side. Plus 11v plus 30. Factor it. It's going to be v plus 6v plus 5. And then set up your number line. Close dot. Okay, negative 10. That's going to be 10 plus 6, negative 10 plus 5, positive. So negative 10 was true. So we're going to shade in the direction that negative 10 is. How about negative 5.5? And that's negative, so that's false. So we're not going to shade that section. Aria, no. And then let's try 0, because that's going to be 6 times 5, which is 30. Oh, that'll be true. BB, mommy's almost done.
Bye, Dad. Bye.
Interval notation. So then in interval notation, this would be negative infinity to negative 6. Negative 5 to infinity. She just walked out. She just said bye and left. All right. Let me go retrieve her. So for this one, we're going to get everything on one side, but I want it all to be positive. So I'm going to say u to the third minus 15u squared plus 36u. But then I also prefer for my 0 to be on the other side. So like that. Go get her. I'll be back in 2 seconds. Baby. Will we bring the tray inside? No, we're Aria. Aria. Pick your train.
Yeah.
We're almost done. Quick, your train. Can you draw me something? Aria. 9 and 4, no. 12 and 3. So then I have 0, 12, 3. Close dot. Test a number less than 0. Let's try -1. Positive? No. About 2? It's 20, so true. How about 5? -70, so 5 is false. And then how about 15? So that's positive, so true. So that in interval notation, this would be 0 to 3, union 12 to infinity. Okay. I think we did these. So with the absolute value inequality, if you have a less than, you make it a compound inequality like this. Subtract the 7, so that would be -16 is less than 2r is less than 2. Divide by the 2. And so then in interval notation, that would be -8 to 1. We did do these because I remember screwing this one up last time. So when you have greater than, you solve for your absolute value first. Oops. So we would start by subtracting the 6. Then we would divide by the 8. And then the greater than inequalities, you would say, okay, well then that means that either 9v plus 4 is greater than 5, or 9v plus 4 is less than -5. And if this had had the or equal to, both of these would have had the or equal to. If this would have had the or equal to, both of these would have had the or equal to. So you just follow with whatever's in the original. Okay, -4 divided by 9, or -4 so then in interval notation, you'd have to put this first. Oof. That was a lot today. All right. I think everybody needs a break.